All right, so for the last section, we're going to talk about something called optimizing. And if you want to optimize something, you're looking for a maximum value or you're looking for a minimum value. Okay, so I want maxes or mins. So what's going to happen is the way we're going to organize is two different ways. We're going to take the information that we know, so the information we can make an equation from, and that's going to be the algebra side. Okay, and then the information that we're optimizing will it will say, give me this as a maximum or give me this as a minimum. And that's going to be the calculus side. Calculus, okay? From there, on the algebra side, solve for one variable. I don't care which one it is, but sometimes it'll be easier to pick one over the other. So solve for one variable. Okay? Substitute it into your calculus. Take a derivative. So differentiate. Set it equal to 0 and solve. So remember, when you take a derivative and set it equal to 0, you're finding a max or a min. So the issue is we've just got some multiple unknowns. So we're going to be working with two variables. So we're going to solve for one variable. Substitute that one variable into our calculus portion, and then take a derivative so that we're actually just working with one variable so we don't have to go back to implicit differentiation. Okay, and then solve it, because you'll set it equal to 0 and solve. You'll know one of the values, whichever variable you're working with, you'll know that value. Well, then you can back substitute into here. So back substitute here, and then you'll know what the other variable is. Okay. So that's what we're going to be doing. And I'm just going to go ahead and dive in. So that was like the shortest intro ever. We have, hang on, I cannot find my mouse. All right. What just happened? There it is. All right. So I've got, find the dimensions of a rectangle with a perimeter of 80 feet that has the largest possible area. So first of all, the algebra side, I'm looking for a perimeter of 80 feet. So remember, that's distance around is your perimeter. And then I want the area to be as big as possible. So choose your variables. I'm going to say length times width. And then here's length and width. So what do I know? I know that my perimeter, so this is the algebra side. Okay, my perimeter is an L and a W and an L and a W, or two L's plus two W's needs to be 80. Okay, so that is the algebra side because it gave you an equation. Now the calculus side says I want the largest area. I want to maximize my area. Well, how do I find area? Length times width needs to be a max. And again, this is one of my little hints right here. Instead of setting it equal to anything, I'm going to put max until I take a derivative. Then I'll set it equal to 0. And it's just a little mental thing for me to track. And so that I know when I've done what. Okay. So come back over here. I've got my two equations. I know which one is algebra. I know which one is calculus. So I need to solve for one variable. Well, right now I know I can divide everything by 2. So I have an L plus a W is a 40. And now I don't care which one you want by itself. Do you want this to be L equals, or do you want this to be W equals? It doesn't matter at this point. So usually what I'll look for is it easy to sub in over here? And since it doesn't matter because it's just multiplication, then who cares? So I'm going to subtract W from both sides. So L is going to be the same thing as a 40 minus W. Okay, what do I do with that? You've isolated one variable. So now come over here and substitute that variable in for here. So instead of writing an L times a W, I'm going to write a 40 minus W times a W. Okay, so 40 minus W times W needs to be a max. Okay, so there's my L, and so here's the issue. In calculus world, we were dealing with two variables. Now I used algebra to condense it down to one variable, and that's going to make my life a whole lot easier when it comes to differentiation. So you can either do product rule, or you can distribute and just go term by term. So I'm going to distribute. I've got 40W's minus W squared, and that needs to be a max. So I haven't done any calculus yet. But here we go. What's the derivative of 40W? It's 40. What's the derivative of a negative W squared? It's a negative 2W to the first. And now I have taken a derivative. Okay, so now I set it equal to 0. So if that's the case, I'm going to go ahead and solve for W. So I get 40 equals 2W, divide both sides by 2. I added W over, now divide both sides by 2. So W must be 20. Well, now come on back over here. I need to know what L is. If W is 20, then L equals 40 minus W. Well, W is 20. So L must be 20, which means if this is 20 and this is 20, that makes this 20 and that makes this 20. So if you've got a rectangle with all four sides being equal, you actually have a square. Okay, so a given perimeter, but you want to maximize area, is going to be a square. All right, let's try it again. So I have a ranch. It's a large ranch. I lost my pen. Oop, found it. All right. So we're just going to waste paper and start over again. All right, so here's my pretty picture. I have a river. Look at this river. And I have fencing going on one side of the river, and these are supposed to be equal. Sorry, I didn't draw it that way. All right, so this side equals this side. And I've got 3,028 yards of fencing, and I need to enclose a rectangular piece of grazing land situated along the straight portion of a river. So again, this side and that side are the same. I just drew it crooked. All right, so fencing is not required along the river. What are the dimensions of the largest area that he can enclose? So let's just say that this is a Y, and this is a Y, and this is an X. And again, remember, I drew this stupid. Okay, so these two sides are equal. Okay, so what do I know? I know that if I add all three of these up together, so X plus 2Y, I need to use 3,028 yards of fencing. So this is the algebra side. And then what do I do with the calculus side? The calculus side is going to be the largest area that I can enclose. Well, how do I find area? Area is just length times width. So I have X times Y needs to be a maximum. Now this one isn't going to be necessarily the same as the last one because I only have 3 sides to deal with for perimeter instead of 4. So if you look at this, this is what I'm talking about. I want to solve for a variable. I don't give a rip which one. It doesn't matter over here which one because it's just multiplication. But when I come over here, it's going to be easier to get X by itself. So that means get rid of the 2Y. So I have X equals 3,028 minus 2Y. And now I can substitute that in over on the calculus side. So X equals 3,028 minus 2Y. So there's your X. Times Y needs to be a maximum. And I'm going to clean it up first. Again, you can do product rule if you want to. I'm going to go ahead and distribute. So when I distribute my Y, I get 30,028Y minus 2Y squared needs to be a maximum value. Have not done calculus yet, have only done algebra, so now we're ready to take a derivative. So this derivative is 3,028 minus 4Y needs to be 0. Okay, that needs to be 0. And now I can solve. So I'm going to add 4Y to both sides. And now I'm going to divide both sides by 4. So 4 goes into 3028. I don't know. 4 goes into 37 times. 4 goes into 22 5 times with 2 left over, 7. So I know that Y is 757. I need 757 yards. So this part is 757 and this part is 757. Well, I can only use 3028. So shove your y value of 757 into here. So x is going to be 3028 minus 2 times 757, which I will not attempt to do in my head. All right, so we have calculator is 3028 minus, and then 2 times 757 gives me 1514. So x is 1514. So this side is 1,514 yards. And each of these sides, which are not drawn to scale, because remember they're the same, I just drew them stupid, is 757 yards. All right, so let's try one more. And we have enclosing an area again. Okay, so look, it's another rancho. Has 3,420 yards of fencing to enclose a rectangular piece of grazing land along the straight portion of a river, and then subdivide it by means of a fence running parallel to the sides. No fencing is required along the river. So what are the dimensions of the largest area that can be enclosed? So let's draw a straight river this time. Here's my river. All right, here's this side. Here is this side. Here's this side. And I'm told that this is x, which makes that x. I'm told that this is y, but I'm also told that there's a third fence in there. So 1, 2, 3. So he is x as well. Okay, so I just need to figure out how to do this thing. So if I set this up as algebra, remember you are given algebra. And then when I want area, the area is simply going to be x times y. So for the calculus side, I'm going to get xy needs to be a max. But now I got to be really, really careful. How much fencing do I need? I need 3 x's plus a y. So 3 x's plus a y needs to give me 3,420 yards. So 3 x's and a whole y needs to give me 3,420 yards. So now I can easily solve for y. So y is going to equal 3,420 minus 3x. And I'm going to substitute that in here. So I know that this is going to be x times 3,420 minus 3x. So I'm going to go ahead and do the substitution because I'm kind of running short on space and time. All right, so if I shove this in, I'm going to get a 30. This is going to be, all right, so I got a 3,420 times x. So all I'm doing is substituting this y in right here, and I'm just doing the distribution by in my head. So I get x times 3,420 is 3,420x minus 3x times x is minus 3x squared, and that needs to be a max. So I just took x and distributed it here so that it was x times y. So take a derivative, I get 3,420 minus 6x needs to be 0. So I'm going to add 6x and divide by 6. So x needs to be, 6 goes into 34 5 times, 6, 570. Okay, let's just make sure so I don't mess up. Because you know I never do that. Hang on. Stop it. All right. So I've got 3,420 divided by 6 is 570. Woot! All right. So what do I know? I know that this is 570, this is 570, and this is 570. I need to know how much y is. So put your 570 right here. So y equals 3,420 minus 3 times 570, which is going to be 1710, which is going to be 1710. So y is 1710. Okay, so this is 570, 570, 570. That's 1710. So you've got all your fencing used, and you've got maximum area for all the cows to eat their stuff. All right, so we're going to come back for one more video.